So I'm going to be going over the budget. As of right now, what we've had paid for is about $400 worth of stuff. We've ordered 97 parts. This includes everything we will need to finish both the DRB and the DIM. That's $56. We did the PCB fabrication for the DRB. That ended up being $345, and that's with $250 student discount and a $395 tooling fee waive. We're estimating a PCB fabrication of $200. This is based off of Gerber files from past control cards. All you need to get fabricated at a professional facility is you send in the Gerbers, they give you a quote. So I just sent in the Gerbers of ones that TI had on their website. And then PCB assembly for the DIM is estimated at $350, doing the same quote process. So as of right now, our total is $950. This was drastically different than a week ago. When I finally did quotes a month ago, they changed them by like $600, so I had to find a new company to use. Next slide. So the fabrication, we have 4-layer boards, which is what makes it difficult. We can't do CNC because we're using a lot of surface mount parts. And then we also can't do chemical etching because it's 4 layers, and there's no way to get around doing 4 layers with the specifications TI needs. So there's top and bottom layer. These are just copper traces. Ground layer, what's really useful about the ground layer, since a lot of our parts are connected to ground, you just drill a hole and go straight to ground. You don't have to route it or anything. Kelvin is the middle layer. It's just another copper layer. We have full drill holes, contacts, overlays, soldering mask, and labels. This is kind of expensive. The overlay is all the tags. Solder mask, since we're doing surface mount parts, it's easier to solder. If the solder is already on there, you just heat up the traces, it sticks in. This is our quote. This is, we're doing the 5-day, and the $250 discount isn't included in that, so that's where the price came from before. This is the company we ended up using. We got 4 different quotes. They ended up being the cheapest after working with them. Next slide. Oh, also fabrication for the DIM card is going to be cheaper because the area is what makes the board expensive. Our DRB is 5 by 5 inches, and our DIM is going to be about 1 inch by 4 inches. But the problem with the DIM card is we have to get custom specs, which is a 2-week turnaround. Also, the assembly is a week turnaround. The reason we have to do custom specs for the DIM is because it has gold fingers, and these are the, when you have like a computer slot, the little gold tabs at the bottom, and they're also, the board is cut at a triangle shape, so it's expensive and it takes longer to get back. So for the DRB, the good thing is it's all surface mount parts that are the bigger size, the SSOP. This means that the ECE shop upstairs can assemble for free, so, and with a 1-day turnaround, so that saves us a lot of money. That would be another $350 roughly. The problem though is the DIM has 1 chip that we can't get soldered on by the ECE shop, and that's an LQFP. The pins are very, very close to each other, and they just don't have the means to do it. So this is the quote if we got all the chips soldered on for the DIM with a 10-day turnaround, $361. We're still trying to work out something where they just solder that 1 chip on for us, and then we take it up to the shop and get everything else done for free. I'll have more quotes coming soon for that. Oh, and that quote was from the same company that we used before. So we have kind of a lot of risk since we're so tight on budget. We delayed PCB layout design. This is for us like getting all our designs done and sent, like the schematics done. Whatever delay we have, we still got to take into account the 2 to 3 weeks turnaround process to getting it back. And the same thing with the delayed PCB fabrication. We had a week delay just because the files they wanted weren't in the right format. Incorrect DRB design. Why this is such a huge risk factor and our biggest risk is the parts in green down here are what we've been given. This is the hardware part of our project. We have a PC software and the hardware connection. Then we have our control card for the ECE480 and the Cortex M3. We were given the Cortex M3. We're making our own ECE480, but our end goal is to drive a motor that we're given. And the DRB 8824, which is in the process of getting back to us right now since we shipped that out, is the shortest path for us to complete our project. But if it's wrong, we can't finish it. So we got that out early so that we can make corrections to it if there's something wrong. And then an incorrect ECE480 design. At this point, once we get it shipped out by the end of this week, we'll have a 2-week or 3-week turnaround, and if there's something wrong, we'll have to either pay a lot of money to get it back faster, or just not be able to pay for it at all with our budget when it's slide. So our agenda, we sent the DRV out to the fabricator, that's completed. We're sending the DIM out at the end of this week. I put 40% completed. We have all the schematics, the layouts all done. The only problem is we've been trying to get the gold fingers that I was talking about. There's not much material online for how to do that. And with the software we're using, it's relatively new, and TI just started using it. We haven't been able to find any design files for reference. So we've been doing a lot of prototyping, just getting 2-layer boards made upstairs to make sure that we have everything in the right place before we ship it out. So we can't afford to do anything wrong with it. So Stellaris coding and testing. I didn't put the ECE480 on here since we have mapped the ports that we won't have to change anything in the code. So once we get that back, we'll load it. Should be good to go with that part of the project. Stellaris coding though, we're still waiting on the debug tool so that we can actually start probing them. We just got them 2 weeks ago and they didn't send us the tool to program it. So that's only about 5% done. But once we get the DRV back, we'll be spending all our time coding the Stellaris. And once that's done, our project will be done. Any questions? And these are all the parts that we have right now. And our facilitator is Dr. Wang, and he's in the back.
Any questions for the class? Come on, help me out, somebody. All right, well, I had a question, but you answered it, and it dealt with the risk of having such an expensive fabrication process and being over budget on just one run of the fabrication. What if it doesn't work?
Yeah, we also had a week delay because of, once we realized that the price was, initially it was supposed to be $165 and they came back to $750. So I canceled the order, talked to a sponsor. He said there's no way this is possible to do for under $500, and he just told me that a couple days ago.
So what are you going to do about the $400 over budget you're already showing?
He wants me to talk to you first and then talk to you. So meet up after class.
All right, well, we better talk about that.
Yeah. But as of right now, with what we have done, we can still complete most of our project without getting the rest of our budget.
I've got a question actually. What pin pitch or what package size is that LQLP? Excuse me, LQLP chip. Is it like a 144 or?
It's just a little bit below whatever the SS
120
is.
Okay.
It's not under the chip or anything. It's still got the pins.
Yeah, it's still got the leads. You might be able to find someone to hand solder that, like myself. I used to do it. I used to work in a lab. We always hand soldered the LQLPs. I'm not trying to diss the guys upstairs or anything, but they're not young anymore. So.
Yeah. Okay, well, I'll talk to you about that.
All right, good, thanks.